Hello everyone, we're back to Lemon Code 21. In this session, we'll learn the basics of Golang together with some exercises. This video is just a sharing of how I learned Golang, and hopefully, it can help you too. Let's get started. Here's the agenda we'll cover while learning basic Golang. First, we'll begin with the history of the Golang programming language. The Go programming language, commonly known as Golang, has a history rooted in its development at Google using the C programming language. It was later released to the public as an open-source project in 2009. The language gained significant traction when it played a crucial role in the creation of Docker in 2011. Since then, Golang has become increasingly popular in the development community, especially for building modern technologies. Many innovative tools and platforms, including Kubernetes, Prometheus, CockroachBee, and others, have been developed using the Golang language. Its simplicity, efficiency, and performance have made it a preferred choice for developers in various domains. Why you must learn Golang. The Golang language is very simple. It doesn't take long to learn it. Golang supports good concurrency programming, where we currently live in the era of multi-core processors. Golang supports a garbage collector, so there is no need to do memory management manually like in C. One of the programming languages that is on the rise. Okay, this is a little explanation of how the Golang programming language works. If you look at the image, the file with the Go data type will be compiled by the computer into a binary file which will then be read by the computer. Before starting, you need to set up or install Golang. Open Google and search for Golang. Go to the official Golang website and download the version that corresponds to your operating system. In this case, I'm using Windows, so I'll download the Windows version. After downloading, proceed with the installation. Once the installation is complete, open the terminal and type Go version to check the installed Golang version on your PC. This command will display the Golang version you have installed. Create project. Projects in Golang are usually referred to as modules. To create a module, we can use the following command in the folder where we will create the module. Go mode init module name. There are actually many more features of Golang modules, but we will discuss them in a special class discussing Golang modules. First, we run the go mode init script. Once done, it will create a Go mode file, indicating that the Golang project is now ready to be used. Create program. Golang is similar to the C/C++ programming languages, where there needs to be something called the main function. The main function is a function that will be executed when the program runs. To create a function, we can use the func keyword. The main function must be located within the main package. Semicolons in Go are not mandatory, meaning we can add semicolons or not at the end of our program code. Now, let's create the main.go file. We specify the package as main, since it will be the main program. We create the main function because, in Golang, it is unique and necessary for execution. There can only be one main function in each Golang project. We will print Hello World. To run the program, you can use the command go run main.go. When you try this, you should see the Hello World message displayed in the terminal. You can also build the project using the go build command. After building, an executable file.exe on Windows will be generated, which can be run separately. Let's try it. Now it should work. All right, let's move on to the next topic. Number data type. There are two types of number data types, namely integer and floating points. All right, let's proceed with writing for integers. It's very simple. We'll print the word 1 with an integer, then 2 with a string, 2 with an integer, and finally, we'll write 3.5. Let's run it directly to see the results according to their data types. Exercise. Number 1. Create an integer variable value with the value 42, then convert the value to the float 64 data type. Store the result in the float value variable. Number 2. Create a variable pi with a value of 3.14159. Use the math round function to round it to an integer. Print the result. Sure. Let's answer question number 1. We'll create an integer variable named value with a value of 42. Then, we'll create another variable and convert it to a floating point number. Finally, we'll print both variables. Now, for question number 2, we'll create a variable named p with a value of 3.1415. Next, we'll create a second variable named rounded p and round the value of pi using the math round function. Finally, we'll print the value of the p variable. Boolean data type. The Boolean data type is a data type that has two values, namely true or false. In Golang, the Boolean data type is represented using the bool keyword. We will try to write the Boolean data type. First, we will write true and false. Now we run. Exercise. Declare a variable isLoggedIn without assigning an initial value. Print its default value and use the default value to determine if the user is currently logged in. Print the result. Now we answer questions from practice. We create a variable of type Boolean. Now we print variable isLoggedIn. If we look at the default data type, Boolean is false. String data type. String is a character set data type. The number of characters in a string can be 0 to infinite. The string data type in Golang is represented by the string keyword. String data values in Golang always start with the character, double quotes, and end with the character, double quotes. Now, let's write strings in Golang. We'll create an example to print lemoncode 21 and lemoncode 21 YouTube. In Golang, there is a len function to determine the length of a string. Additionally, you can access individual characters in a string using square brackets and the desired index. Let's try running this, and you will see some numeric values as a result. These need to be converted into strings. Exercised. Number 1. Declare two string variables, first name and last name. Concatenate them to create a full name. Print the result. Now, let's answer the questions from the exercise. We will create string variables according to the instructions in question number 1. Once done, we'll create a third variable named full name and concatenate the values of the first name and last name variables. Finally, we'll print the result. Variable. A variable is a piece of storage containing data temporarily to work with it. The most general form to declare a variable in Golang uses the var keyword, an explicit type, and an assignment. Var name type equals expression. Golang variables naming convention. These are the following rules for naming a Golang variable. A name must begin with a letter and can have any number of additional letters and numbers. A variable name cannot start with a number. A variable name cannot contain spaces. If the name of a variable begins with a lowercase letter, it can only be accessed within the current package. This is considered as unexported variables. Golang variables naming conventions. If the name of a variable begins with a capital letter, it can be accessed from packages outside the current package. This is considered as exported variables. If a name consists of multiple words, each word after the first should be capitalized like this: emp name, emp address, etc. Variable names are case-sensitive. Car, and car are three different variables. Let's start by creating a variable. Variables can be declared using the var keyword, followed by the variable name and its data type. For example, let's create a variable name with the value lemoncode 21 and then print it. Next, we override the name variable with the value YouTube and then print it. After making this change, you can run the code, and when you check the results in the terminal, you will see the updated output. Next, you can declare a variable without specifying its data type by directly assigning a value to it. For instance, let's create a variable called mypc and then change its value to my old PC. The third method allows you to declare a variable without using the var keyword by using the shorthand equals and assigning the value directly. To change its value, you simply use the equals operator. To do variable overhead, simply use the equal sign. Lastly, you can declare multiple variables using var keyword and parentheses. For example, I have variables named first name and last name. Let's go ahead and run it, and the result should be successful. Exercises. Number 1. Declare a variable called age, and assign your age to it. Print the value of the variable. Number 2. Declare two variables, name and country, and assign your name and country to them, respectively. Print both variables on the same line. Number 3. Use the short declaration syntax to declare and initialize a variable called temperature with the value 25. Print the value. Sure, let's answer the first question. We create a variable named age with the data type int, and then we print its value. Next, for the second question, we create multiple variables such as name and country. We set name to John and country to USA. After that, we print the values. For the third question, we answer by creating a variable named temperature with the value of 25. Here, we use the shorthand notation without the var keyword, but with a colon and an equal sign. Then, we print the temperature. Let's run it to see the results. Constant. A constant is a variable whose value cannot be changed after it is initially assigned. The process of creating a constant is similar to creating a variable, with the key difference being the use of the keyword const instead of var. When creating a constant, it is mandatory to initialize its value at the same time. Let's start by creating a constant. We'll create two constants named first name and last name, both with the data type string. It's important to note that the value of a constant cannot be changed. If we attempt to run the code, an error related to the immutability of constants will occur. Now, to create multiple constant declarations, you can use the const keyword followed by parentheses containing the desired constants. We'll try defining two constants using this approach. Again, keep in mind that the values of constants cannot be modified. Exercises. Number 1. Declare a constant named pi with the value 3.14159. Print the value of the constant. Number 2. Declare two constants, days in week and hours in day, representing the number of days in a week and hours in a day, respectively. Print both constants. Let's address question number 1. We will create a constant named pi with a value of 3.14159, then print its value. We'll try to run the code, but an error will occur. Let's first remove the incorrect constant. For question number 2, we will create two constants, days in week and hours in day. We will print their values. When we run the code, it will succeed, and the output will match the expected values. Now, let's proceed to the next topic. Type conversion. Data type conversion. In Golang, sometimes we need to convert data types from one type to another. For example, we want to convert the data type in 32 to in 63, etc. Now, let's try performing data conversion. We create a variable named value 32 with the data type in 32. Next, we create another variable named value 64 and attempt to convert data from 32 to 64. Finally, we create a last variable and try to convert 64 to integer 16. We print the results to observe how integer conversion works. Next, we extract a character from a string to convert it to a string. We create a variable named name with the value lemon-code 21. We retrieve the character at index 0 with a new variable. Finally, we convert the variable e to a string, naming the new variable string. Exercises. Number 1. Declare an integer variable int var with a value of 42. Convert it to a float 64 variable float var. Print both variables. Number 2. Declare a string variable str_var with a numerical value like 123. Convert it to an integer variable int var. Print both variables. Number 3. Declare a float 64 variable float var with a value of 5.678. Convert it to an integer variable int var and then back to a float 64 variable new float var. Print all three variables. In task 1, we created a variable invar with the value 42. We then converted it to a float 64 by declaring a variable float var. Upon printing the variables, we observed that the integer value transformed into a float. Moving on to task 2, a variable named str_var was created with the string data type. The goal was to convert this string to an integer using a function like @wav. After the conversion, the results were printed to verify the success of the process. Finally, in task 3, a variable float var3 was initialized with a float value. We proceeded to convert it to an integer and then back to float 64. The printed results demonstrated the data transformation in accordance with the specified data types. An operator is a symbol that tells the compiler to perform certain actions. The following lists describe the different operators used in Golang: arithmetic operators, assignment operators, comparison operators, logical operators, bitwise operators. This arithmetic operators table, you can use it as a reference. This assignment operators table, you can use it as a reference. This comparison operators table, you can use it as a reference. This logical operators table, you can use it as a reference. This bitwise operators table, you can use it as a reference. First, we create three variables, a with a value of 10, b with a value of 10, and c by adding a and b. The result is printed. Next, we create variables x and y with values 15 and 25, respectively. We then replace the value of x with that of y. Finally, we will print the results. After that, we perform an addition operation on x by adding the value of I using the plus equals assignment operator. Finally, we will print the results. We also perform a subtraction operation on x by subtracting the value of I using the equals assignment operator. The results are printed. Lastly, we perform comparison operations using the equality equals inequality, equals less than or equal to, equals and greater than or equal to, equals operators. After running the code, the results should align with the described operations. Exercises. Number 1. Declare two variables, a and b, with values of your choice. Perform and print the results of addition, subtraction, multiplication, and division. Number 2. Declare a variable total with an initial value. Use assignment operations to add, subtract, multiply, and divide the variable by another value. Print the variable after each operation. Number there. Declare two Boolean variables, is sunny and is warm, with values of your choice. Use logical operations, ANDO, to determine if it's a good day for outdoor activities. Print the results. Question 1. We will create two variable declarations, a and b, with values 10 and 5 respectively. We will then print the results of addition, subtraction, multiplication, and division. Finally, we will print the results. After printing, we will execute the program. Question 2. Next, we create a variable with a value of 50. We will perform various assignment operations on the total variable. First, we will add a value using an assignment operation and print the result. Then, we will subtract a value using another assignment operation. Finally, we will print the results. Afterward, we will multiply by 2 Finally, we will print the results and divide by 3 using assignment operations. Finally, we will print the results. Question 3. For the last question, we will create 2 Boolean variables, is sunny and is warm, both initialized with default values of true. We will then create conditions using logical AND and OR. The first condition checks if both is sunny and is warm are true, resulting in true. The second condition checks if either is sunny or is warm is true, also resulting in true. Arrays. Array is a data type that contains a collection of data of the same type. When creating an array, we need to determine the amount of data that the array can hold. The array's capacity cannot be increased after the array is created. Declaring an array. var int array 5int. Var, this keyword, is used to declare variables in Go. Int array, this is the name given to the array. 5int, this part, specifies that int array is an array of integers, and it has a fixed size of 5. In the Go programming language, we have created an array named countries. To initiate the array, we utilize the var keyword, followed by the array name, square brackets indicating the array size, and the data type of the array elements. For instance, we added the values USA, Japan, and UK to the array at indices 0, 1, and 2, respectively. By running the program, we observe the results to confirm that the array has been successfully initialized. Values have been added at specified indices, and the complete array has been printed. Now we will print all the array values that we have created. Array declaration can be used. The statement initializes an array X of type int with the values 1, 2, 3, 4, and 5. The length of the array is explicitly set to 5, and the values are provided in the specified order within curly braces. When using ellipses in array initialization, Go automatically determines the size of the array based on the number of elements provided within the curly braces. In this example, the size of the array is not explicitly mentioned, and Go infers the size from the number of elements provided. Here, the array E is of type int and has a size of 3, as there are their elements within the curly braces. Exercises. Number 1. Declare an array named numbers with integer values 1 to 5. Print the array. Number 2. Declare an array named fruits with 3 string values representing fruits. Print the second element of the array. Number there. Declare an array named ages with integer values. Modify the third element of the array to a new value and print the updated array. In response to the first question, we have initialized an array named numbers using the Go programming language syntax. The array is declared to have a size of 5 and is of the integer data type. Within the array declaration, we have provided 5 integer values to populate the array. Following the declaration, the program prints the contents of the numbers array. This ensures that the array is limited to a size of 5 as specified and contains the assigned integer values. In response to the second question, an array named fruits has been created in the Go programming language. The array is defined to have a size of 3 and consists of elements of the string data type. Specifically, the array is initialized with the values apple, banana, and orange. Subsequently, the program prints the second element of the fruits array by accessing index 1, which corresponds to the value banana. This example illustrates the creation of a string array in Go, showcasing the ability to assign values during initialization and retrieve specific elements using index notation. In response to the final question, an array named ages has been created in the Go programming language. This array is defined to have a size of 4 and consists of elements of the integer data type. Initially, the array is initialized with the values 25, 30, 35, and 40. Subsequently, the program modifies the third element of the ages array by updating its value to 36. This demonstrates the capability of Go to dynamically change the values of specific elements within an array. Finally, the program prints the entire ages array, showcasing the updated values. Slice. The slice data type is a slice of array data. Slices are similar to arrays. The difference is that the size of the slice can change. Slides and arrays are always connected, where slices are data that access some or all of the data in the array. Var, it's the keyword used in Go for variable declaration. In slice, it's the name of the variable, indicating that it's a slice of integers. Int, it specifies the type of the variable, indicating that it's a slice containing elements of the integer data type. Slice can be created using the built-in function make. When you use make, one option you have is to specify the length of the slice. Var, this keyword is used to declare variables in Go. Slice, this is the name given to the variable. Make, string, 10, 20. This part initializes the slice. The make function is used to create a slice, and it takes 3 arguments. String indicates that slice is a slice of strings. 10 represents the initial length of the slice. It starts with a length of 10. 20 represents the capacity of the slice. The capacity is the maximum number of elements the slice can hold without reallocation. The following is a useful slice table to help create data type slices. Slice function table, which can also be useful to help use slices. We have created a variable named slice in Go, which is initialized as a slice of strings containing the values USA, UK, and JAPA, ANGen. Following the initialization, a print statement has been employed to display the contents of the slice variable. This concise piece of code captures the essence of creating and displaying a string slice in Go. By declaring the slice and assigning specific string values, we gain the ability to easily manipulate and showcase the contents of the slice. The subsequent print operation allows us to observe the outcome, verifying the successful creation and initialization of the string slice. In Go, the creation of slices can also be accomplished using the make function, allowing for the specification of both length and capacity. In this instance, a slice is created with a length of 10 and a capacity of 20 using the make function. Subsequently, a print statement is employed to display the resulting slice. This approach with the make function is particularly useful when there is a need to explicitly set the initial length and capacity of a slice. The length determines the number of elements initially present in the slice, while the capacity defines the total space allocated for potential future elements. The print operation provides a means to examine the slice and confirm its dimensions. Continuing with our exploration, we proceed to access specific elements within a slice using array indices in Go. This approach allows us to retrieve individual items based on their positions in the slice. Subsequently, we employ a print statement to visually inspect and observe the outcome of the slice access. The process of accessing slice elements through array indices underscores the versatility of Go's syntax, providing a straightforward means to interact with and retrieve precise data from slices. Array indexing enables developers to pinpoint and extract specific values from the slice, facilitating nuanced data manipulation. In Go, the addition or expansion of a slice can be accomplished using the append function. This dynamic operation allows for the seamless inclusion of new elements into an existing slice. Following the append operation, a print statement is executed to display the resulting slice. The use of the append function showcases the flexibility and adaptability inherent in Go's slice management. It provides a convenient way to extend a slice with additional elements, accommodating changes in data requirements during runtime. Now it's time for us to print to see the results. As you can see, the German data has been entered into the slice. Furthermore, we can perform the action of copying a slice in Go by utilizing the copy function. This operation involves duplicating the content of one slice into another. Following the application of the copy function, we proceed to execute the program, initiating the copy process. Now it's time for us to print to see the results. Exercises. Number 1. Declare a slice named numbers with integer values 1 to 5. Print the slice. Number 2. Declare a slice named colors with string values representing colors. Append a new color to the slice and print the updated slice. To address the first task, we initiate the process by declaring a slice named numbers in Go. This slice is initialized with values ranging from 1 to 5, providing a sequential series of integers. Following the declaration and initialization, a print statement is executed to display the content of the numbers slice. To address the second task, we proceed by creating a slice named colors in Go, initialized with the values red, green, blue, and yellow. Following the initialization, we add the color purple to the slice. Subsequently, we execute a print statement to observe the contents of the colors slice. Map. In an array or slice, to access data, we use an index number starting from 0. Map is another data type that contains the same data collection, but we can determine the type of index data type that we will use. Simply put, map is a key value collection data type, keyword value, where the keywords are unique. They cannot be the same. In contrast to arrays and slices, the amount of data we enter into a map can be as large as possible, as long as the keywords are different. If we use the same keywords, the previous data will automatically be replaced with new data. In Golang, maps are written with curly brackets, and they have keys and values, creating an instance of a map data type. var, this keyword is used to declare variables in Go. Employee, this is the name given to the variable. Map string int, this part specifies that employee is a map, where keys are of type string and values are of type int. Mark, 10, Sandy, 20. This part initializes the map with two key value pairs. The keys Mark and Sandy are associated with the values 10 and 20, respectively. Below is a table map that will be useful for you. Let's create a map with string keys and integer values. The keys Mark and Sandy are associated with the values 10 and 20, respectively. Now it's time for us to print to see the results. In Go, we can declare a map using the make function. Let's create a variable named newEmployee and utilize the make function to initialize a map with string keys and integer values. Subsequently, we add values to the map. The process is straightforward. We reference the variable newEmployee within square brackets and provide the key, followed by the assignment of the corresponding value. For instance, if the key is Mark, we assign a specific integer value to it. The way to access values from a map is very easy. Just write the variable and then write the desired key name. To add a new key value pair, we use square brackets and assign a value to the newly created key. We fix the value associated with John with a new value, namely 180. To delete elements from a map in Go, you can use the delete function. This function takes two arguments, the map from which you want to delete elements and the key of the elements to delete. Exercises. Declare a map named countries where keys are country names, strings, and values are their populations, integers. Add new country. Modify the population some country and delete an entry for a specific country and print the updated map. In addressing the first task, we initiate the process by creating a variable named countries in Go. This variable is a map that associates countries, USA, China, India, and Brazil, with their respective population values. Following the initialization, we add a new entry for Japan, with a population value of 123. Subsequently, we update the population data for China, modifying it to 1558. This demonstrates the ease with which Go allows us to dynamically alter values associated with specific keys within a map. Finally, as the last step, we attempt to remove the entry for Brazil from the country's map. Utilizing the delete function, we can efficiently eliminate the data associated with Brazil. Now it's time for us to print to see the results. After we try it, we can see that the results have changed according to the command we ran. If-else. Like most programming languages, Golang borrows several of its control flow syntax from the C family of languages. In Golang, we have the following conditional statements. The if statement executes some code if one condition is true. The if-else statement executes some code if a condition is true and another code if that condition is false. The if-else statement executes different codes for more than two conditions. The switch Case statement selects one of many blocks of code to be executed. In this scenario, we start by creating a variable named name with the assigned value John in the Go programming language. Following this, we construct an if condition to check whether the value of name is equal to John. If the condition is met, meaning the value of name is indeed John, the program executes a print statement that outputs the message "Hello, John." In the subsequent refinement of the code, an else statement has been incorporated to extend the conditional logic. If the value of the variable name is not equivalent to John, the program will seamlessly transition to the else block. Within this block, a print statement has been implemented to output the message "Hello, everyone." In the further refinement of the code, an additional else if statement has been introduced before the else block. This else if statement checks whether the value of the variable name is equal to David. If this condition is met, the program executes a specific code block, printing the message "Hello, David." Let's run it if we see all the values are correct. In the context of Go programming, the if statement can be expressed using the if short statement construct, which allows for the declaration and evaluation of a variable in a single line. The len name function is used within the if short statement to dynamically determine the length of the name variable. If the length is greater than 5, the program prints name is very long. Otherwise, it prints name is too short. Exercises. Number 1. Declare a variable score and assign a value. Use an if-else statement to check if the score is greater than or equal to 60. Print pass if true, otherwise print fail. Number 2. Declare two variables, sunny and temperature. Use nested if-else statements to check if it's sunny, and if the temperature is greater than 25 degrees Celsius. Print appropriate messages. In addressing the first task, we commence by declaring a variable named score with a value of 75 in the Go programming language. Subsequently, a conditional statement is employed to evaluate whether the value of score is greater than or equal to 60. If this condition is met, the program executes a print statement, outputting the message pass. Otherwise, it prints fail. To address the second task, we initiate the process by declaring two variables in Go, sunny with the Boolean value true and temperature with the numeric value 25. Following this, a conditional statement is crafted to evaluate whether it is sunny. Sunny is true, and, within this condition, further assesses if the temperature exceeds 25. Based on the evaluation, the program executes corresponding print statements. If sunny is true and the temperature is greater than 25, the program prints, "It's a hot and sunny day." If the temperature is less than or equal to 25, it prints "It's sunny but not very hot." Conversely, if sunny is false, indicating a non-sunny day, the program prints "It's not sunny today." Now it's time for us to print to see the results. Switch case. Apart from if expressions to branch, we can also use switch expressions. Switch expressions are very simple compared to. Usually switch expressions are used to check conditions in one variable. In the first scenario, we create a variable named John and implement a switch case statement in the Go programming language. The switch is designed to evaluate the value of John, and based on the cases provided, it executes specific print statements. If the value of John is David, the program prints "Hello, David." If it is James, the output is "Hello, James." For any other value, the default case prints "What's your name?" Moving on to the second scenario, we introduce a variable named today, representing the current time. A switch case is then constructed to evaluate the day component of the today variable. If the day is less than 5, the program prints "Clean your house." If the day is less than 10, it prints "Buy some snacks." In the default case, if no specific conditions are met, the program prints no information available for that day. Exercises. Number 1. Declare a variable grade and assign a letter grade A, E, D, C, D, or FF. Use a switch statement to print a message based on the grade E. G, excellent, good, average, poor, fail. In addressing the first question, we create a variable named grade with the value B in the Go programming language. Subsequently, we implement a switch case statement to evaluate the value of grade. Based on the evaluated grade, specific print statements are executed. If the grade is AE, the program prints "Excellent." If the grade is B, it prints "Good job." For the grade C, the output is "Average." If the grade is D, the program prints "Poor." In the case of an F grade, it prints "Fail." The default case is designed to handle any grade that doesn't match the specified cases, and it prints "Invalid grade." Now it's time for us to print to see the results. For loop. In programming languages, there is usually a feature called repetition. One of the looping features is for loops. In this example, we create a simple loop in the Go programming language by initializing a counter variable with the value 1. The loop is constructed using a for statement, with the condition set to execute as long as the counter is less than 10. Within the loop, a print statement is used to output the message loop, along with the current value of the counter. The counter is then incremented by 1 in each iteration. Now it's time for us to print to see the results. For with statement, in for, we can add statements, where there are 2 statements that can be added in for. Init statement, namely the statement before the for, is executed. Post statement, namely a statement that will always be executed at the end of each loop. In addition to the previous example, another way to implement a loop in Go is by using the standard for loop structure. In this case, we create a variable named counter and initiate a for loop with 3 components: initialization, condition, and post statement. The initialization sets the counter to 1, the condition checks if the counter is less than 10, and the post statement increments the counter in each iteration. Now it's time for us to print to see the results. For range, for can be used to iterate over all collection data. Data collection examples include array, slice, and map. In the subsequent example, we employ the range keyword to iterate over the elements of a array in the Go programming language. Prior to this, we initialize a array containing strings. The for loop is then structured to utilize the range keyword, facilitating the iteration over each element of the array. Within the loop, two variables, index and element, are employed to represent the index and value of the current element, respectively. The program proceeds to execute specific actions for each iteration, such as printing the index and element values. Exercises. Use a for loop to print even numbers from 2 to 10. Use an if statement to determine if a number is even. Declare an array of strings fruits with a few fruit names. Use a for loop with range to print each fruit. In addressing the first question, a solution is implemented in the Go programming language using a for loop to print even numbers from 2 to 10. The loop is structured with an index variable, I, initialized to 2, and a termination condition set for less than 10. The loop's post statement increments by 2 in each iteration. Within the loop, an if statement is introduced to check whether the index, when divided by 2, yields a remainder of 0, indicating an even number. If this condition is satisfied, the program proceeds to print the current value of I. Now it's time for us to print to see the results. For the second question, we approach it by first creating an array named fruits with the values apple, banana, orange, and grape in the Go programming language. Subsequently, we utilize a loop with the range keyword to iterate through each element of the fruits array and print each fruit. Function. Previously, we knew about a function that must be created so that our program can run, namely the main function. A function is a block of code that is deliberately created in a program so that it can be used repeatedly. The way to create a function is very simple. Just use the keyword func, followed by the name of the function and the code block containing the function. After creating a function, we can execute the function by calling it using the function name keyword followed by an opening parenthesis, a closing parenthesis. In this scenario, we create a simple function named sayHello in the Go programming language. The purpose of this function is to print the message hello. The function is then invoked within the main function of the program. Function parameter. When creating a function, sometimes we need external data, or what we call parameters. We can add parameters to the function, maybe more than one. Parameters are not mandatory, so we can create a function without parameters like we previously created. However, if we add parameters to a function, then when calling the function, we must enter data into the parameters. In this example, we create a function named add in the Go programming language, which takes two input parameters, namely x and I, both of type integer. Inside the add function, the operation of adding the two input parameters is executed, and the result is then printed. Subsequently, this add function is invoked within the main function of the program. Function return value. Functions can return data. To tell that a function returns data, we have to write down the return data type of the function. If we declare the function with a return data type, then in the function we must return data. To return data from a function, we can use the return keyword followed by the data. In this example, we define a function named addReturn in the Go programming language. The function takes two input parameters, x and y, both of type integer, and it returns an integer value. Within the addReturn function, an addition operation is performed on the input parameters x and y, and the result is then returned. Subsequently, this addReturn function is called within the main function of the program. Returning multiple values. Functions can not only return one value, but also multiple values. To tell if a function returns multiple values, we have to write all the return value data types in the function. In this example, we create a function named rectangle in the Go programming language, which takes two input parameters, x and y, both of type integer. The function is designed to have two return values, namely area and parameter, both of type integer. Inside the rectangle function, an addition operation is performed on the input parameters x and y to calculate the area and perimeter of a rectangle. The computed results are then returned as multiple values. Subsequently, the rectangle function is called within the main function of the program. Ignoring return value. Multiple return value must capture all its values. If we want to ignore the return value, we can use the sign _. In this example, we create a function named getFullName in the Go programming language, which is designed to have two return values of type string. The function, when invoked, returns two strings, John and David. Subsequently, the getFullName function is called within the main function of the program. To test it, we define a parameter named firstName and use an underscore to discard the second returned string. Finally, we print the result. Named return values. Usually when we say that a function returns a value, we only declare the return value data type in the function. However, we can also create variables directly in the return function data type. In this example, we define a function named getCompleterName in the Go programming language, structured to have two return values, both of type string. Within the getCompleterName function, the operation is simple, returning two strings, John and David. Subsequently, the getCompleteName function is invoked within the main function of the program. To test it, we create parameters named firstName and lastName. Finally, we print the result. Function as parameter. We can not only store functions in variables as values, but we can also use it as a parameter for other functions. In this example, we create a function named getHelloWidthFilter in the Go programming language, which takes two input parameters. The first parameter, name, represents a name, and the second parameter, filter, is a function. Inside the function, the provided filter function is executed, modifying the input name based on certain conditions. Specifically, we define a sample filter named spamFilter, which checks if the input name is equal to dog. If true, it returns the string dot, and if false, it returns the original name. This getHelloWidthFilter function is then called within the main function of the program. Now it's time for us to print to see the results. Number 1. Write a function called rectangleInfo that takes the length and width of a rectangle as parameters and returns the area and perimeter with named return values. Number 2, write a function called counterWithState that returns a closure. The closure should maintain a counter variable and also accept an increment value as a parameter. Number 3, write a function called processNumbers that takes a slice of integers and a callback function. Apply the callback function to each element of the slice. In addressing exercise number 1, we create a function named rectangleInfo in the Go programming language. This function takes two input parameters, length and width, both of type float64, and returns two values, area and perimeter. Inside the function, calculations for the area and perimeter are performed, and the results are then returned. The rectangleInfo function is invoked with the input values 4 and 5, and the obtained results are printed. Moving on to exercise number 2, we craft a function called counterWithState. This function has a return value of integer and includes an inner function named increment. Within the increment function, an increment operation is performed, and the function itself is returned, creating a loop where the count continuously increases. The counterWithState function is called with various input values, such as 2, 3, and 5, and the results are printed. Finally, addressing the last question, the initial step involves creating a function named processNumber that takes a slice and a callback function as input. Inside the function, a loop iterates over the input numbers, applying the callback function to each element and printing the results. To test the first function, a slice containing integers from 1 to 5 is created. The processNumber function is then called with the created slice and a callback function that performs multiplication on the input. The results are observed by executing the code. Now it's time for us to print to see the results. Variadic Functions. The parameter in the last position has the ability to be used as a vararg. Varargs means the data can receive more than one input, or think of it as a kind of array. How are they different from ordinary parameters with the array data type? If the parameter is of type array, we must create the array first before sending it to the function. If the parameter uses varargs, we can send the data directly if there is more than one. Just use a comma. Sometimes there are cases where we use a variadic function, but it has variables in the form of slices. We can make slice a vararg parameter. Now, we are exploring the creation of a variadic function in the Go programming language. The function we'll define is named sumol, which takes an input parameter named numbers of type integer, and it is marked as variadic by appending 3 dots before the parameter name. Within the function, there is code to incrementally add the values from the input parameters. Firstly, we will test the function by creating a variable named total and assigning it the result of the sumol function with individual values 10, 11, 12, and 13 passed as arguments. Subsequently, the result is printed. Secondly, we will test the function using a slice as an input parameter. We create a variable named numbers containing a slice of integers and then we pass this slice to the Variadic function sumall. The resulting sum is then printed. Observing the outcome, it should demonstrate that the Variadic function can be successfully executed. Exercise. Write a Variadic function called calculateAverage that takes an arbitrary number of floats as parameters and returns the average with a named return value. In this exercise, we are addressing question number 1 by creating a function named calculateAverage in the Go programming language. The function takes an input parameter named number of type float, and it is marked as Variadic by appending 3 dots before the parameter name. The return type is specified as float64. Inside the calculateAverage function, there is code to calculate the average of the input numbers, and the result is returned. Next, in the main function, we test the calculateAverage function by creating a variable named averageResult and assigning it the result of calling the Variadic function with inputs 3, 4.5, and 6. The calculated average is then printed. Now it's time for us to print to see the results. Anonymous function. Previously, every time we created a function, we would always give the function a name. However, sometimes it is easier to create a function directly in a variable or parameter without having to create a function first. This is called an anonymous function, or a function without a name. In this example, we create a variable named area assigned to an anonymous function in the Go programming language. The anonymous function takes 2 input parameters, L and B, both of type number, and returns an integer. Subsequently, we print the result of invoking the area variable with the inputs 20 and 30. When creating an anonymous function in Go, it is important to pay attention to the variable declaration. In this case, the area variable is declared with an anonymous function assigned to it. The function signature specifies 2 input parameters, L and B, and the return type is an integer. Exercise. Declare a variable multiply and assign an anonymous function to it. The function should take 2 integers as parameters and return their product. In addressing question number 1, we create a variable named multiply assigned to an anonymous function in the Go programming language. This anonymous function takes 2 input parameters, x and I, both of which are of type int, and returns an integer. Within the function, there is code to execute the multiplication operation between the input values x and I. Following the creation of the anonymous function, we declare a variable named product and assign it the result of invoking the multiply variable with the inputs 2 and 4. Subsequently, we print the result of the multiplication operation. Recursive function. A recursive function is a function that calls its own function. Sometimes in our work, we often encounter cases where using a recursive function is easier than not using a recursive function. An example of a case that is easier to solve using recursive is factorial. In this scenario, we are exploring the creation of a recursive function in the Go programming language. Specifically, we establish a recursive factorial function named factorial that takes an input parameter named value of type integer and returns an integer. Within the function's execution, a conditional statement checks if the value is equal to 1. If true, the function returns 1. Otherwise, it returns the product of the current value and the result of invoking the factorial function with the value decremented by 1. Subsequently, we test the recursive factorial function in the main function by invoking it with the input value of 10. This recursive approach showcases Go's capability to elegantly handle repetitive operations, illustrating the flexibility and expressive nature of recursive functions. Exercise. Write a recursive function called Fibonacci that takes a non-negative integer as a parameter and returns the nth Fibonacci number. In addressing question number 1, we create a Fibonacci function in the Go programming language. The Fibonacci function, named Fibonacci, takes an integer input n and returns an integer. Within the function's execution, there is a conditional statement that checks if the input n is less than or equal to 1. If true, the function returns the value of n. Otherwise, it returns the result of invoking the Fibonacci function recursively with the decremented value of ni. Subsequently, we test the Fibonacci function by invoking it with a specific input value and print the result. The Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding ones, usually starting with 0 and 1. The recursive implementation of the Fibonacci function demonstrates the elegance and expressiveness of Go in handling mathematical algorithms. Closures. Closure is the ability of a function to interact with surrounding data within the same scope. Please use this closure feature wisely when we create applications. In this simple example, we are exploring the concept of closures in the Go programming language. We declare two variables, L and B, representing length and breadth, respectively. Within this context, we create a closure, an anonymous function that takes no parameters but captures the values of L and B from the outer scope. Inside the closure, we execute a multiplication operation, multiplying the captured values of L and B. The result is then printed. The closure, in this case, encapsulates both the function and the environment in which it was created, allowing it to access and utilize the specific values of L and B at the time of its creation. Closures in Go provide a powerful way to create self-contained, encapsulated functions that can operate within a specific context or environment. Defer. A defer function is a function that we can schedule to be executed after a function has finished executing. The defer function will always be executed even if an error occurs in the function being executed. In this scenario, we are delving into the concept of defer in the Go programming language. First, we create a function called logging with the content print done call function. Next, we define another function named runApplication, where we invoke the logging function using defer at the beginning. Following that, we print runApplication. When we execute the runApplication function within the main function, the results demonstrate that the initial execution is the runApplication function rather than the logging function. This illustrates that the defer keyword in Go is used to delay the execution of a function until the surrounding function, in this case, runApplication, completes its execution. Panic. The panic function is a function that we can use to stop the program. The panic function is usually called when a panic occurs while our program is running. When the panic function is called, the program will stop, but the defer function will still be executed. In this example, we explore the behavior of panic in the Go programming language. We begin by printing the string start. Subsequently, we introduce a panic with an error string. Following that, we add a print statement for end. When we execute the program, the process unfolds in a way that, upon encountering the panic execution, an immediate error is triggered, preventing the subsequent print statement for end from being executed. The use of panic in Go is reserved for exceptional or unrecoverable situations. When panic is called, it halts the normal execution flow and starts unwinding the stack, executing any deferred functions along the way. Recover. Recover is a function that we can use to capture panic data. With recover, the panic process will stop, so the program will continue to run. In the created example, a function named triggerPanic is defined. Inside this function, there is a deferred function call that invokes the recover function. The primary purpose of this deferred function is to capture any panic strings that might occur during the execution of the surrounding code. In Go, the recover function is used in conjunction with deferred functions to handle panics gracefully. When a panic occurs, the normal flow of the program is disrupted, but deferred functions are still executed, and the recover function allows us to catch and handle the panic. In the context of the provided example, the triggerPanic function sets up a mechanism to recover from panics and capture the associated panic string. Struct. A struct is a data template that is used to combine 0 or more other data types into one unit. Structs are usually data representations in application programs that we create. Data in structs is stored in fields. Simply put, a struct is a collection of fields. In this scenario, a struct named customer is created with attributes name, address, and age, each having respective data types of string and integer. Following the struct definition, we proceed to create a variable named customer derived from the customer struct. Subsequently, we input the attributes, set the name to John, address to Jeladline, no, and age to 25. Then, we print the details of the customer. Additionally, we demonstrate an alternative method for initializing struct attributes by using curly braces without explicitly specifying each attribute. This approach can be employed when you want to set multiple attributes during initialization without specifying each one individually. Exercised. Define a struct called address with fields for city and country. Extend the person struct to include an address field. Create a person with an address and print their details. In this scenario, we begin by creating a struct named person with attributes name, address, and age. Additionally, a function called printDetail is defined, which takes a person as an argument and prints the person's name and address. Following this, we create another struct named address with attributes city and country. Subsequently, a struct named person with address is created, combining the attributes of a person and an address. Moving on to the main function, an instance of the person with address struct is declared and initialized with values. The attributes are set to David for name, 25 for age, Riverside for the address, New York for the city, and USA for the country. Finally, the details of the person with address instance are printed. Interface. Interface is an abstract data type. It has no direct implementation. An interface contains method definitions. Usually, the interface is used as a contract. Interface implementation. Any data type that corresponds to an interface contract is automatically considered to belong to that interface. So we don't need to implement the interface manually. This is somewhat different from other programming languages, where when creating an interface, we have to explicitly state which interface we will use. Firstly, we create an employee interface that contains the printName method. Subsequently, we define a truck-named attribute, within which we have two attributes, id of type integer and username of type string. Following that, we proceed to implement the printName method of the employee interface. The implementation prints the employee's ID and username along with a generic employee name. Next, we declare a variable E1 as an instance of the employee interface. We initialize its attributes with specific values for ID and username. Finally, we invoke the printName method through the interface, resulting in the display of employee details. Now it's time for us to print to see the results. Blank interface. Golang is not an object-oriented programming language. Usually in object-oriented programming, there is one parent data at the top which can be considered as all the data implementations in the programming language. An example in Java is Java lang object. To handle cases like this, in Golang, we can use an empty interface. An empty interface is an interface that does not have a single method declaration. This means that all data types will automatically be implemented. The interface is empty. It also has a type alias called any. In this illustration, we delve into the concept of empty interfaces in the Go programming language. Let's consider a function named ups that returns an empty interface. The primary characteristic of an empty interface is its ability to encapsulate values of different types. Initially, let's set the return value of ups to an integer, representing a simple use case. In practice, the ups function could be designed to perform various operations or computations. Upon calling the ups function within the main function and storing the result in a variable named empty, we witness the dynamic nature of the empty interface. The ability to print and work with a value of any type, in this case, an integer, showcases the power of the empty interface. Now, let's explore further by altering the return type of the ups function to a string. Continuing this exploration, we modify the return type once again, this time to a Boolean. Despite this change, the function remains consistent in its ability to return values of various types. This exemplifies the abstraction provided by the empty interface, allowing for generic and adaptable code. Nil. Usually in other programming languages, objects that have not been initialized automatically have null or nil values. Different from Golang, in Golang, when we create a variable with a certain data type, the default value will automatically be created. However, in Golang, there is nil data, which is empty data. Nil itself can only be used in several data types, such as interface, function, map, slice, pointer, and channel. In this scenario, we are exploring the creation of a function named printf-not-nil in the Go programming language. The primary purpose of this function is to take an integer input, specifically a pointer to an integer, int, and execute a set of instructions based on the condition of the pointer. Within the function printf-not-nil, there is an execution block that checks whether the value pointed to by the parameter pt is not equal to nil. If the condition holds true, indicating that the pointer is pointing to a valid memory address, the value of the pointer will be printed. However, if the pointer is nil, indicating that it is not pointing to any memory address, a message such as pointer is nil will be printed. Let's explore the function in action. First, we execute the function with the input value nil. In this case, the condition within the function will evaluate to false, and the message pointer is nil will be printed. This demonstrates the handling of a nil pointer scenario. Next, we create a variable, say num, and assign it the value 12. Subsequently, we pass the address of this variable, denoted by and num, to the printf-not-nil function. Since the pointer is pointing to a valid memory address, the address of num, the function will print the value pointed to by the pointer, which is 12. Pointer. Pass by value. By default in Golang, all variables are passed by value, not by reference. This means that if we send a variable to a function, method, or other variable, what is actually sent is a duplicate of its value. Detailed explanation of pass by value. Upon examining the scenario, illustrated in the given context, we observe the presence of two distinct objects, address1 and address2. The process involves duplicating the object, address1, to create a separate instance, address2. This implies that address2 is an independent copy of address1 with its own set of attributes. In this scenario, we are working with a type employee defined as a struct with attributes ID, name, and address, all of which have string data types. Subsequently, we initialize a variable employee1 with specific values such as ID equals 1, name equals John, and address equals Chicago. Now we aim to create another variable employee2 by referencing employee1. It's essential to note that when you create employee2 with a reference to employee you own, any changes made to the attributes of employee2 will only affect the data within that specific instance. In other words, if you modify the address value of employee2, the change will be localized to employee8u, and it won't impact the value stored in employee uin. Pointer. Pointers are the ability to make references to data locations in the same memory without duplicating existing data. Simply put, with pointer capabilities, we can create a pass-by reference. Pass-by reference with pointers. Pass-by reference is a parameter passing mechanism in programming languages where the reference to the memory address of the actual parameter the argument is passed to the formal parameter of the function or method. This means that changes made to the formal parameter inside the function affect the original value of the argument outside the function. Operator and out. To create a variable with a pointer value to another variable, we can use the AND operator followed by the variable name. To achieve a scenario where changes to employee 2 also impact employee 1, we can utilize pass-by reference with pointers, employing the asterisk operator. By doing so, both employee 1 and employee 2 will share the same reference, and modifications to one will directly affect the other. This mechanism ensures that the two variables are pointing to the same memory location, creating a synchronized behavior between them. However, if we want to create a new reference for employee 2, we can easily do so by using the ampersand AND operator. This allows us to generate a fresh reference to a different memory location for the new object. The resulting behavior is such that changes made to employee 2 will not influence employee 1, as they are now pointing to distinct memory locations. It is worth noting that when we modify employee 2 using the asterisk operator, the reference relationship changes dynamically. Anyone altering employee 2 subsequently affects employee 1, which originally pointed to the same address as employee 2. This creates a dynamic and interconnected relationship between the two objects. Operator. When we change a pointer variable, only that variable changes. All variables that refer to the same data will not change. If we want to change all the variables that refer to the data, we can use the operator. By utilizing the asterisk operator in conjunction with pointers, we can dynamically alter the reference of employee 1 to a new employee object, such as switching from the original John to a different employee. Let's say David. This results in both employee 1 and employee 2 having a new reference pointing to the employee object representing David. The significance of the asterisk operator in this context lies in its ability to dereference the pointer and modify the underlying value it points to. When applied to employee 2, it effectively changes the object being referred to, and since employee 1 shares the same reference, it is automatically updated to point to the new employee object, in this case, David. Operator new. Previously, to create a pointer using the AND operator. Golang also has a new function that can be used to create pointers. However, the new function only returns a pointer to empty data, meaning there is no initial data. Next, let's explore the creation of pointers using the new keyword. Here, we initialize a variable E1 with new employee and subsequently create E2 by assigning it the value of E1. Following this, we modify the address attribute of E2 to be New York. Upon printing both values, we observe that both data now have a pointer data type. The introduction of the new keyword serves as a convenient method for creating pointer data types in Go. The utilization of new simplifies the process of creating pointers by automatically allocating memory for the specified type. Pointers in function. When we create parameters in a function, by default, it is passed by value, meaning the data will be copied and then sent to the function. Therefore, if we change the data in the function, the original data will never change. This makes the variable safe because it cannot be changed. However, sometimes we want to create a function that can change the original parameter data. To do this, we can also use pointers in functions. To make a parameter a pointer, we can use the operator in the parameter. Let's consider a scenario. We create a function named changeAddress, where the purpose is to modify the address attribute of the employee to Nevada. Where we initialize a variable M1 representing an employee named Norman, with the address set to San Francisco. However, upon printing the variable M1 after calling this function, we notice that the name and address remain unchanged. To address this issue, we need to modify the function's input parameter by introducing the pointer operator and using the address of operator. By doing so, the function will receive a reference to the original employee object, allowing it to directly modify the attributes. Upon implementing this adjustment, we observe that the address attribute now correctly reflects the change to Nevada. Pointers in method. Even though the method will be attached to the struct, the actual struct data that is accessed in the method is passed by value. It is highly recommended to use pointers in methods so they don't waste memory because they always have to be duplicated when calling the method. In exploring pointer methods, we establish a function named married. The intention is to add the title Mr. to the name of the employee when this function is called, creating a variable ep1 representing an employee named David with an address in London. However, upon printing the result, we notice that there is no observable effect and no changes occur. To address this, we need to modify the employee struct by adding an asterisk before the type in the function receiver parameter. This modification signals that the function expects a pointer to the struct, enabling it to directly manipulate the struct's attributes. Upon implementing this change, we observe that the name attribute of the employee struct indeed undergoes the intended transformation. Package. Package is a place that can be used to organize the program code that we create in Golang. By using packages, we can tidy up the program code that we create. Packages themselves are actually just folder directories in our operating system. By default, Golang files can only access other Golang files that are in the same package. If we want to access Golang files that are outside the package, then we can use import. In this scenario, we are exploring the creation of a package in the Go programming language. The process involves creating a directory named helper with a file named base package, Go. Once the file is opened, we declare that it belongs to the helper package using the package helper statement. Subsequently, within this package, we define a function named sayHello that takes a parameter name of type string. The function's execution involves returning a string with the message hello concatenated with the provided name parameter. After creating the helper package, we proceed to another file, let's say main. Go where we intend to utilize the functionalities provided by the helper package. To achieve this, we need to import the helper package at the beginning of the main. Go file. The syntax for importing a package is straightforward. Import package path. Once the package is imported, we can directly reference and use the functions defined within it. For instance, if we import the helper package, we can call the sayHello function from this package in our main. Go file by invoking helper. Package initialization. When we create a package, we can create a function that will be accessed when our package is accessed. This is very suitable when, for example, if our package contains functions to communicate with the database, we create an initialization function to open a connection to the database. To create a function that is accessed automatically when the package is accessed, we simply create a function with the name init. We are creating a directory named Package Initialization and adding a file named basepackageInitialization.go within it. Within this file, we initialize a variable named connection with the value miscall and define an init function. Inside the init function, we assign the value miscall to the connection variable. Additionally, we create a function named getAtAC that returns the value of the connection variable. Moving on to the main Go file, we import the package initialization package and invoke the getAtABase function from this package. The result will be the value of the connection variable, which is miscall. This practice exemplifies the use of package initialization in Go. The init function within the package gets executed automatically when the package is imported. This is particularly useful for initializing package-level variables or setting up conditions that need to be satisfied before the package is used. Access modifier. In other programming languages, there are usually keywords that can be used to determine access modifiers for a function or variable. In Golang, to specify an access modifier, just name the function or variable. If the name starts with a capital letter, it means it can be accessed from other packages. If it starts with a lowercase letter, it means it cannot be accessed from other packages. In this scenario, we have created a package named helper with a file named basepackage. Within this package, we have defined two variables, version with a lowercase initial letter and application with an uppercase initial letter. The purpose of capitalizing the initial letter of application is to make it accessible from outside the package, effectively making it public. Additionally, we've created two functions, sayHello and sayPrivate. The former is exported and the latter is not. Moving on to the Go file, we import the helper package and use its exported variables and functions. We create a variable named application and initialize it with the value of application from the helper package. This showcases the visibility of variables declared with an uppercase initial letter, allowing them to be accessed outside the package. Furthermore, we create a variable named say and assign it the value returned by the sayHello function from the helper package. This demonstrates the accessibility of exported functions from outside the package. Now it's time for us to print to see the results. Making an error. To make an error, we don't need to do it manually. Golang has provided a library to easily create helpers, which is found in the errors package, We will discuss the package in detail in a separate material. In this example, we create a function named checkerer that takes an integer parameter called value. The function returns both an integer and an error. Within the function, we check if the input value is equal to 0. If it is, the function returns 0 and a custom error message stating value is 0. If the input value is not 0, the function returns the input value and a nil error, indicating success. Moving on to the main function, we declare two variables, result and initializing them with the values returned by the checkerer function with an input of 5. Subsequently, we check the value of the variable. If it is equal to nil, we print the result. Otherwise, we print the error message. Create custom errors. Because error is an interface, so if we want to create our own error, we can create a struct that follows the contract of the error interface. In this scenario, we begin by defining a custom error type, a struct named NotFoundError, which includes an attribute message of type string. Subsequently, we create a function called error that returns the error message stored in the message attribute of the NotFoundError struct. Next, we craft a function named SaveData with an input parameter ID of type string and a return type of error. Inside the SaveData function, there is a condition that checks if the ID is not equal to James. In case the condition is met, the function returns an instance of the NotFoundError struct with the message data not found and a nil error. Proceeding to the main function, we initialize an error variable with the result of the SaveData function using the input string. Subsequently, we check if the error variable is not equal to nil. If this condition is true, we further inspect whether the error type is of the NotFoundError struct. If it is, we print data not found, otherwise we print the error message. In conclusion, having covered the basics of Golang, our journey now takes us to explore essential topics in the Go programming language, such as the standard library, modules, unit testing, routines, databases, and web development. Delving into these areas will provide a comprehensive understanding of Golang's capabilities, enabling developers to harness its power for building efficient, scalable, and reliable applications.